Hey folks, and welcome to the introduction to the Scorekeeper R package, which is an R package for reproducible algorithmic scoring of multi-item assessments. So I am going to be breaking this up into 4 parts. We're going to talk about why Scorekeeper is needed, what it is, and then talk a little bit about how to get started and some bugs and features. We're going to put those in 4 separate videos for you. Starting off, why do we need Scorekeeper? Why should you use this package? Well, Scorekeeper is an R package that is focused on multi-item measures that are common across social, psychological, behavioral research. And examples of these types of measures that you might commonly use are like self-report scales, diagnostic interviews, neuropsychological testing, anything that has many items that go into a scale, or even just a few items that go into a scale that you then need to, before you're going to analyze that data, to manipulate it in some way and for cleaning purposes, to score it, to do something with it. And most multi-item measures do require some amount of data cleaning and what I'm going to call data aggregation before you are actually going to be able to put that as your dependent variable or independent variable in an analysis. So examples of this might be things like reverse scoring. Some items in a particular psychological measure might be reverse scored. You would have to recode some things. So you may find that whenever someone made that survey initially, that they put in, a 1 is never, and you actually think that never should be coded 0, for instance. And so you might want to recode some of your variables. You also might want to rename some of your variables. And so the default names that might come out of your Qualtrics, your REDCap, might be a little funky or not informative. And so you might want to do some renaming before you're going to use them analytically. Another thing you might want to do is manage your missing codes, change your negative 999s to NAs if they need to be changed, or other missing variable codes. You might want to manage those a little bit. You also might want to account for skip logic. So there are, in a lot of online questionnaires, for instance, it might be that if someone answers that first question and they say, no, I have never smoked any cigarettes in my life, they are not going to get 10 follow-up questions about the frequency of smoking, but you actually want to go back in there and make all of those zeros so you don't accidentally remove all those people in your analyses when you know that they should be zeros and not removed. Things like that. Another thing you might want to do is create sum or mean scores. So a lot of psychological measures, social measures, things like that might have validated ways to score a particular measure or assessment that you want to create that score to replicate what is done in the literature. And then finally, you might want to do some algorithmic scoring. So this could be like a diagnostic type thing where you have to meet like the first 2 criteria and then 3 of the next 5. And then if you meet that, then you also have to have, a functional impairment kind of thing. And lining that up and doing that algorithmically in order to then categorize individuals later can be something that you want to do before you're ever going to use that derived variable in your analyses. So those are some reasons that you're going to want to use something like Scorekeeper, or have the, and you probably right now just have this in a lot of different data cleaning scripts. People might have them in different parts of your lab. It might be kind of like this lore that goes down, and somewhere in your lab you have a file of scripts, or someone has a few, another person has a few, and what we're trying to do with Scorekeeper is like tighten that up and put it all into one place and do it in a way that is super easy and super useful. So some, but not all of your data sets are going to have data that is pre-cleaned and aggregated. And a pro to this is that you're going to have a little bit less data cleaning and some built-in harmonization. However, if you have a lot of really pre-cleaned stuff, then you are going to have a little bit less analytic flexibility. So say you actually find out, oh, they coded this measure as, never equals 1 or something like that, but I actually want to code it a little bit differently. Then if it's already pre-cleaned and preset, then you may have a little bit less ability to rescore things. But you can still have that opportunity if you're going to go back in and do it yourself. And when collecting your own primary data, you actually have to often clean and aggregate this data prior to analysis. And I haven't found any super empirical research about this, but some reports that I have dabbled in and found suggest that about 50 to 80% of data analyst time or data scientist time can be spent on this cleaning initial processes. These cleaning scripts are often developed independently across labs and projects and also might not be well organized. And finally, another thing is that a typical way that individuals or labs might have a process for cleaning data might be that all of the data is kind of in its raw-ish form. Maybe there's a little bit of pre-processing that goes on for some of the most commonly used data, and then everybody kind of independently, as they work on this new project and that new project, takes the data that they need and does the cleaning just for that little piece, right? Here, Scorekeeper is meant to be this framework that you can use, that we're using in my lab, to score all of the data in the entire project as it comes in so that it is all ready, cleaned, ready to go for any project that you need, and that we know that it's cleaned in the same way across anybody who wants to use the data. And another thing I just want to note here is that reproducible scoring requires high-level skill. So I think one of the reasons that that data scoring and aggregation and data cleaning has not gotten has been essentially swept under the rug as far as processes and learning statistics and learning what you need to developing your pipelines, is that it is kind of seen as a less than task, but we actually know that it's very, very important for reproducible science, and that it does take high-level logical skills. So you need to develop reproducible documented code, document the order of your data transformation. So, you need to recode something before you're going to submit, things like that. And document the decision-making and how you derived a specific score. So if you just end up with a score at the end of this is the aggregate score for everyone's score on this scale, but you don't know how you got it or you can't reproduce that, then that's not very useful, especially to someone who might want to check it or to reproduce your data in a new data set. You also need to cite your scoring decision. So why did you decide to, put that item with the other ones versus, maybe there's 2 or 3 different ways to score a particular measure in the literature, which is often the case that I find that there's some variability in how the factors play out depending on different samples, depending on different populations, depending on different studies. And so why did you choose to score your measure in that particular way that you did if you are creating an aggregate score? And you also want to just store both your raw and your cleaned data and kind of have that all organized, have that in one place. All of this is really high level stuff, and it's and I think we need to treat it as such. And most importantly, reproducible scoring of multi-item assessments that the Scorekeeper package allows you to do can facilitate open science and collaboration. So organized scoring procedures can facilitate replication, So scoring code can be a resource for others using similar measures to use in a different sample. This code can be shared in instances where the data cannot. So I have some data that I use called the ALLSPAC data, or the Avon Longitudinal Study of Parents and Children. I can't share that data, but I can share the code that will allow other people who are using that data to derive the same variables as me if they have the same kind of raw data. Secondly, this allows you to, these organized scoring systems are going to help you in collaboration. This is both within your team and your lab, but it's also across teams, labs, and organizations. We know that we are stronger in numbers, both in terms of when we are able to create collaborations within our own lab groups, but also across the field. I work in the eating disorder field. It's hard to get samples. If we are able to collectively be doing the same kind of procedures and scoring in the same way and say like, okay, I found this here, our meta-analyses are going to be better. The things that we're bringing together are going to be more consistent. So that is another reason to use something like Scorekeeper for organized scoring. It also provides you, and this is a big one, traceable metadata. So if you are using the Scorekeeper package, it will help you to label and define your derived variables and see, okay, where did this come from? What am I doing? And how is this particularly defined and labeled? And it helps you to keep track of that metadata, which is the data about your data, right? It is how you derive that variable. Okay. Last slide here. So, in sum, why should you use Scorekeeper? Because Scorekeeper is an approachable way to do this. So, most study team members and people in the scientific community are not going to have the substantial coding experience necessary to interpret and edit your raw code. So you could say like, oh, I can do this all in R with dplyr. Absolutely you can. And many people that you might be sharing it with might not have that same experience and that same ability to read your code and to understand everything that's going on and to edit it if they want to change something. With Scorekeeper, I'm trying to it's not going to be the most straightforward, but it's in the middle. I think if you follow the guidance of this, my undergraduate researchers have been making these score sheets, and they're capable of kind of developing and understanding what we're doing in our data, and it makes coding and understanding your code more approachable. Scorekeeper is also designed to facilitate a reproducible system for data cleaning, which is approachable for those with little coding experience. So again, this can actually be like an entree into our coding for our, your undergraduates, your kind of beginner level graduate students. It can be this kind of first step to learning how to code in R. Scorekeeper also harmonizes coding practices across analysts. So we know that like different folks may have different ways that they like to approach their coding. And if in my lab, everyone's using Scorekeeper in order to do that initial data cleaning step, then everyone's going to be able to understand the logic and the guide and how things go. So in our lab, it allows us to harmonize coding practices across our analysts. And it also, and the way that it does this is by using a specified consistent format to process and score multi-item measures. Scorekeeper also simplifies our data cleaning. So once you have your score sheet built, and I'm going to talk about what that is in the upcoming parts, it will clean your data and score your multi-item measures with one line of code using your developed score sheets. So if you want to change something, if you want to add a variable, if you want to change the way that you are coding a specific thing, then you can go back into your score sheet, update that, and then just run one line of code to re-update all of your data with that new variable or that new derivation. And the way it does this is it actually manages a lot of the syntax and grammar of data cleaning within the package so that you can just focus on a more narrow set of things to do. All right,